Hello, mathematicians of the world. I am a mini student, and I am here with you on behalf of Alondra Rubio to help her present her math final project. I am going to talk to you about candy for the next few minutes. For visual aid, I have the help of a mini screen behind me and also a support in my legs. Alright, so the other day Alondra bought the cheapest bag of candy she could find. It was a 470-gram bag of nut candy named Super Natilla. It contained 100 pieces of candy claiming that each weighed 4.7 grams. Okay, with this project, Alondra seeks to prove how truthful this brand of candy is being with its customers. She weighed half of the bag in a school's lab scale, placed the data in the cells you are seeing, and proceeded to submit the data to a central limit theorem and a hypothesis testing process. Sounds complicated. Moving on. For this process, the tester must generate two hypotheses. One that supports the usually believed things, call it the null hypothesis, another that rejects the standards and goes crazy. This is the alternative. To do this, Alondra got the normal mean of mu equals 4.7 and the sample mean of mu equals 4.8. A bit higher than expected, huh? Afterwards, Excel provided her with a variance of and a standard deviation of. Our two hypotheses are like this. Null being that the candy weight average is exactly 4.7 grams, as stated in the candy bag. Alternative being that the average candy weight is different than 4.7 grams. Alondra must prove if the 0.1 gram difference between the two means is mathematically relevant to say that the brand is lying about the weight of the candy. Let's look into the procedure page. First, let's assume that the null hypothesis is correct. This pretty curve you see here represents a normally distributed data group. There, in the middle, is our original mean, 4.7. We will get into this curve in a moment. The data group is of 50. This is largely enough to be a normally distributed and submitted into a central limit theorem. Now, as you can see, our nice curve has two more numbers and two shaded critical regions. On my right, 4.694, and on my left, 4.7006. Now, we can clearly see that the sample mean of 4.8 falls quite deep into the critical region of my left. The probability of this happening, if the null hypothesis was true, is of 3.33%, making the sample mean a mathematical relevant proof to reject the null hypothesis. So, yeah, Super Natilla brand is full of lies, but good lies, as they give you more candy than you expect. Alright, that's it from me. Thank you for listening, and now go buy some Super Natilla candy. Bye!